Good day, sir. I am Aramay A. Andor, and this is my report for relative motion rotating axis. So block A, which is attached to a cord, moves along the slat of a horizontal fork rod at the instant shown. The cord is pulled down through the hole at 0 with an acceleration of 4 meters per second squared, and its velocity is 2 meters per second. Determine the acceleration of the block at this instant. The rod rotates about 0 with a constant angular velocity 4 rad per second. So for a given, we have the motion of moving reference. So our V sub O is equal to 0 and our A sub O, our initial acceleration is 0 and our omega is 4k because omega is equivalent to angular velocity and that omega is equal to 0. So for motion A with respect to moving reference, our radius is equivalent to 0.1 since this is 100 mm, so we converted it to meters. So for our V, we have minus 2I because the cord is pulled down. So if we say pulled down, so it is a negative sign. And for our acceleration, we have 4I since it is pulled down. So for our solution, we have there a formula. So A is equal to AO plus dot omega times RA plus omega times R plus 2 omega times B plus A. So our AO here is this 1, 0, and our dot omega is 0 times the radius, which is 0.1, it's still 0. And for our omega, we have 4k, and for our omega again, we have 4k. And for our radius, we have 0.1i plus 2 times omega, which is 4k, times our velocity with respect to moving reference, we have negative 2i, and our acceleration with respect to our moving reference, we have 4i. So 4k times 0.1i, we have 0.4j, and 4k times negative 2i, we have negative 8j. So our equation now is 4k times 0.4j plus 2 times negative 8j minus 4i, then equals to negative 1.6i minus 16j minus 4i. So our acceleration with respect to moving reference, our acceleration will be negative 5.60i minus 16j meter per second squared.